This is Chapter 17, Example 1. This is a very instructive example, real classic and useful digital design circuit. So what it's going to do is take the absolute value of a signed number. Now it's 8-bit signed input, could be negative, could be positive, but it kicks out the magnitude on the output. The output's also 8 bits. This hardware kind of follows the mathematical definition of this, where it needs to make a choice. I'm either going to output the number as it comes in if it's positive, or I'm going to take the 2's complement and output that number if the input number is negative. So once again, it's making a choice. It's either outputting the number as is if it's positive, or it will take a 2's complement if it's negative and output that. The issue is it's doing one thing or the other thing, and it's a classic mux. It's making a decision. There it is. There's my circuit, absolute value. So this name matches this name, of course. So what's interesting is what to do on the input. So I'm going to say a val here is going to go into the input, and also I'm going to have to do 2's complement here for the other value. Okay, so these are all 8-bit. I'll mark these accordingly, and looking good. This is a mux, so it has to choose which of these 2 values here is going to appear on the output of the mux. So something has to make that decision, and in this circuit it happens to be the sign bit of the input. I'll make this 8, but I'm gonna say this is the sign bit. So lastly, if the sign bit's a 0, that means it's positive. That means I'm going to pass along the positive version. If the sign bit's a 1, it's going to pass along the 2's complement of that val input. So the circuit is done as is, except I need to make sure I define this 2's complement box here. This 2's complement box is going to be a classic 2's complement with hardware. We've done this before. So what it's going to do is going to invert all the bits and add 1. So we need a ripple carry adder there. Okay, so this notation here is shorthand notation for meaning there's 8 inverters there. I've grounded the B input, and then I've added a 1. So this is my notation to add 1. So this circuit is doing the classic complementing the input and adding 1, which is my 2's complement. This box here is the 2's comp box right there. So this is a multi-level design. I always have to add that in there. You've seen the circuit before enough times. Pretty much from now on we'll just be just using a 2's complement box and know that you know what goes on inside the box.